Hello and welcome to this video on scientific data downloading and visualization. My name's Marcus Donnelly. I work for a UK-based company called Systems Engineering and Assessment Limited, SEA for short. We're based near the city of Bath in the southwest of England. Our main interest in accessing data over the internet is in oceanographic data, and we've developed software which accesses data using the OPenDAP protocol, does various calculations on it of interest to us, and displays the results using the Bokeh visualization library. And we thought that the data access and visualization parts of the software might be of interest to other people. So that's being made available as open source, and I'll come back later in the video to how you can get access to the source repositories. But it's available from the Python package index, so you can just download it using pip. It's Python 3 software, so you need to have Python 3 installed. And it was developed on an Ubuntu machine using Firefox and Chrome browsers for testing, but of course Python being cross-platform, I'm demonstrating it here on a Windows 10 machine using the Edge browser. So all I've got installed here is Python 3 and pip, and I've installed virtualenv. As you can see, I'm running that here, and I've got it activated. You don't have to use virtualenv, but of course it's a nice way of keeping your libraries more containerized and stopping conflicts. So all you've got to do is to type pip install OPenDAP viewer, which is the name of the package. The name comes from an amalgamation of the words Bokeh, OPenDAP and viewer. Now I've already done this for speed, so when I hit return here you'll see it just says requirement already satisfied. But that's all you need to do, and it will automatically install the package from the Python package index together with all of its dependencies. So it will have been installed into the site package, the relevant site package folder, which for me on Windows will be lib site packages. I think the path's very similar on Linux and presumably on Mac as well. But you just get to the relevant folder under site packages, and there it is. It's just a single web application module here. As I say, there are some dependencies which it will have installed automatically. So to start it up, you just start the Bokeh server in the normal way. And we've got the browser open here, so we should see the window appear. So there we go. So we'll minimize that. And so here we are. I'll maximize that for better viewing. And you can see that I've got there's two main tabs. Bokeh, one of the great things about Bokeh is it enables you to build pretty rich dashboard type applications. You can have multiple tabs with, as you can see, various tables and controls on them. Here I've got a data selection tab, which you'll see in action in a minute, and a visualization tab. I haven't done anything yet, so there's no plots. But the first thing we need is a URL of an OPenDAP server. Now there's lots of these out there. A very useful one is the US National Oceanic and Atmospheric Administration, NOAA website, and they make a huge amount of data available via OPenDAP. And I'm on one of their catalogues now to give you an idea of the sorts of things that are available. We use the World Ocean Atlas quite a lot, and just convenience, I've already bookmarked a server URL which corresponds to the monthly average for a particular month of year, April in this case, on a global 1 degree grid. So I've just copied and pasted the URL in there, and I'm going to open it. And here you can see it loads the dataset descriptor structure, DDS, and you can see all the variables there displayed in a table. I'm interested in temperature in this case, so I'll click on that and get the variable details. And now you can see it's loaded the data attributes structure, so you can get all the information you need to know about the data. It also loads all the dimensions of the data as well. In this case, just one time, because it's a monthly average of 1 month. You've got 56 depths, and as you can see, there's a 1 degree latitude and longitude grid. You can double click on these to edit them if you want, type in new value or use the up and down arrows or whatever. I'm just going to leave it as the full grid for now though. So you can then click a button which gets the plot options, which will depend on your dimensionality of the data, and it'll give you all the options available to plot. I'm going to do a straight long and lat grid here, but I'd like to be able to plot variable depth, so you'll see how the software does that in a moment. And when you click the get data, it will download the data and visualize it. Nice aspect of the software is that by selecting these, you can download only the portion of the data that you need. You don't have to download the entire data set. And here it is. I'll zoom out a bit, just so you can see everything on more or less one page. So yeah, so here you go. So this is the temperature data displayed as a color map. Now this is using a standard, this is using a bokeh image plot and the color bar, but as you can see I've got some custom JavaScript here, which is you've got a scanning cursor, which you can see in the right hand plot there. And what you've got is you've got a volumetric temperature data as a function of lat, long and depth. So here we've got a lat long color map plot at a particular depth, and as you move the cursor it shows you the vertical profile, in other words the temperature as a function of depth at that latitude and longitude. So in oceanographic terms, normally depth is displayed at the top as opposed to at the bottom of the plot, so we can reverse the z-axis and update the display, and you'll see this is now people used to looking at oceanographic data will be a bit more familiar with this now. And you can see as I scan around, you can see some obvious features, like the temperature is obviously higher near the equator than near the poles. As you scan the cursor around, you can see that the structure changes. Towards the upper reaches of the ocean, the temperature tends to be more or less isothermal, which is known as the mixed layer, and then it goes into the thermocline, where it declines fairly sharply with depth. And you can sort of see that structure here. But around the world, you get different temperature profiles, and you can investigate that here. You could also, I'm just using the mouse here to change the depth index now, so you can move, that's 5 meters, 10 meters, 50 meters, etc. And go right to the bottom. If I can click on the bottom here, I seem to need to be able to click right exactly in the right place. As you can see, it looks very different there. And the color map will update automatically, or you can enter values here if you want to fix it. You can also reverse the X and Y axis if you need to. So that's one aspect of the kind of display that it can do. You might want to display a different kind of slice, for example, at a particular latitude. You might want to display the data against depth and longitude. So let's fix this at some, I don't know, 120, somewhere above the equator. Now, if we get the plot options now, you'll notice that they're reduced. You get, you've just got 2 now because the data dimensionality has changed. So we'll plot it against longitude and depth. Now, the depth levels are not on a uniform grid here, so we'll need to do some interpolation to do an image plot. So if you leave it, the interpolation is full blank, it will use the minimum available, which is fine. But if you've got a non-uniform grid for which the minimum value is very fine, then it might be a little slow to do that. But in this case, it's reasonably quick. This time we don't want the z-axis. We want to reverse the y-axis here, don't we? So there you go. So you can see this is you've got a sort of slice all the way through longitude, and you've got but you've obviously got land obscuring the data here. These are big things like continents. Now here there's no line plot to the right because you've only got a single value in the depth plane. But in that case, you can see you've got a scanning data cursor where it'll give you the values of long, depth in this case, and the temperature. So, and it'll do that whatever you're plotting. If you don't have a line plot because you don't have any depth to the plot, it will give you a cursor readout. So, and of course, being a bokeh plot, you've got all the sorts of tools that you've got with bokeh, which are really good. So you can zoom in and out, you can pan and zoom. It's very, very interactive. And when I came across bokeh, I found this was really great because it was the first time I found something that could do this kind of interactive, MATLAB and Matplotlib quality graphics in a web browser. It was very fast, very responsive, and very high quality plot. So in terms of what the data can do, what the software can do, that's pretty much it. But as I say, you ought to be able to download and view any data that's available from an OPenDAP server. I'll just finish with just a bit of information and acknowledgement. So as you saw already, you can get the software straight from the Python package index. It's Python 3, so you need to have the right version of Python. You just use pip to install it. The app itself and the libraries it depends on are available at these public Bitbucket repos, so you can just clone that if you want to. And if you want to find out more about Bokeh, go to this URL. You find out more about that. There's more information on OPenDAP, the OPenDAP protocol here, and more information on the company I work for, SEA, here. So yeah, I'd like to say thanks to the US National Oceanic and Atmospheric Administration, NOAA, for making all that data available. Thanks to the OPenDAP organization and to the Bokeh community for producing some really great software. And if you'd like to, if anyone would like to make any comments on the software or any change requests or anything like that, you've got the public source repos to be able to do that. So please do. I hope that's been useful. Thanks very much for watching.